No! AP Physics. Welcome back to AP Physics. Today we're gonna
Episode 108 of our physics let's play.
Yeah, we're in that episode. Projectile motion is a form of motion in which an object is traveling across the Earth's surfaces in a curved path when the only force acting upon it is gravity.
Normally, in a real-life situation, air resistance would have an impact on the object in projectile motion.
Air resistance would have an impact on an object in projectile motion. However, in this equation, we are neglecting the air resistance. In physics, there are certain rules and concepts one must have to follow in order to achieve the right answer. Two of these concepts is that gravity being the only force acting upon the object causes the velocity in the x direction to be a constant value, and acceleration in the y direction to be only the force of gravity, which is negative 9.81. As I have mentioned before, because the gravity and acceleration is at a constant rate, we can use kinematic equations to solve this problem.
Oh, that's awkward. Okay. So our goal in this equation is to solve a two-dimensional kinematic problem with a non-horizontal initial velocity starting and ending at different heights. Our given is the angle, which is 30 degrees, our v initial, which is 20 meters per second, and our change in y, which is 45 meters. So first, we need to find the time of flight, but we can't do that until we find the initial x and y components of the velocity. To find the initial velocity of the x-axis, we need to do v initial cosine of beta, which is 20 meters per second times cosine 30 degrees. And if we do that, it'll equal 17.3 meters per second. Now if we do the exact same but use sin to find the initial velocity of the y-axis, as you can see, we'll do 20 meters per second times sin to the 30 degrees, which will be 10 meters per second. Now that we have these things, we find the y displacement taking y initial equals 0, which would make y equals negative 45 meters, and v initial y being 10 meters per second. Now that we have all this information, we can do the problem. So we use the change in y equals y minus y o equals v o y t minus 1/2 gt squared. We plug in our numbers. Negative 45 meters or 10 meters per second times c minus 4.0 meters per second squared times t squared. If we solve it all out, we should get the answer of 4.22 seconds.
Okay, so another thing that we can do for this problem is to find the speed when the ball hits the ground. So we're gonna use Vx. This is gonna tell us the speed, like the total speed at impact. So we'll use Vx squared plus Vy squared, and it's the square root of this whole equation. And in using this, we just add up I think it's pretty self-explanatory. And so we have Vx, since it stays constant throughout the entire curve, it stays constant. So we have v initial, we have Vx. We don't have v, which is what we're looking for, but we also don't have Vy. So let's look for that right now. So Vy is equal to, it is equal to v naught y minus gt, and g is just the acceleration. It since it is in free fall and there is no air resistance, it's g. And the negative, instead of putting plus negative 0.8, it's just subtracting. So we have this. we have the v initial in the y direction, we have gravity, and we have the time, so we just substitute. So Vy was 10, as you can recall. G is 9.8, and the time is 4.22. And doing the math, 9.8 times 4.22 equals 41.36, and 10 minus that is negative 31.36 meters per second. Okay, so now that we have the Vy, we can just remember that number, or we can just go back to this and do the math again in our head. So we'll go back to that first equation that I showed you. V equals the square root of Vx squared plus Vy squared. Now we have Vy and we have Vx, so now all we do is substitute and solve. So Vx was 17.3 squared plus, negative, I'm sorry, I forgot to put the negative, negative 31.36 squared, and it's the square root. So 17.3 squared equals, it equals 299. 299.29 plus, so negative 31.36 squared equals, negative, my calculator does that. It's actually positive, it just doesn't count the negative. So it's 983.4496. And we add that up and we find the square root, and our answer should come out to be 35.9 meters per second, and that is the speed at impact.
In order to find a change in distance in the x direction, we can use a formula, a kinematic formula. It goes delta x equals velocity initial in the x direction times time. Our initial velocity in the x direction is 17.3, and the time found by Anthony Castro is 4.22. And if you use your calculator correctly, your change in x should be 73.1 meters.
For sure, this one!
Go. Finally. I made it.
Go ahead.
I made it.
Go ahead.
What?
Say what you're gonna say.
Finally. Oh. Damn. Yeah. No gravity.
35.9 meters per second. No, I'm wrong.